In this lecture, we will discuss what are deployments and why we need them in Kubernetes. When we deploy our application with a replica set, we make sure that it will be always available, because if the pod fails for any reason, the replica set will recreate the pod. The replica set offers also the capability to scale up or down based on the traffic coming to our application. In spite of these advantages, we still have some issues that can affect the user experience when deploying pods with replica sets, especially when we want to move our application from the current version to a new version. Let's understand what problems we have when deploying applications with replica sets. With a replica set, we make our application available to the users by creating the replica set, which will create some pods running the first version of our application. Now, the first version is available and can be accessed by the users. Then the dev team will continue improving the first version by fixing bugs and adding new features. And when the new version is available, we need first of all to remove the pods running the first version by deleting the replica set. Then we update the version of the Docker image. And finally, we recreate the replica set to deploy a specified number of pods running the new version of our application. The problem here is that between the deletion of the pods running the old version and the creation of the new pods running the new version, there will be a downtime when there is no pod to serve the users, and this can affect the user experience. So here we need to find a way to update the version of our application without any downtime. And this can be achieved using deployments. A deployment is another kind of objects in Kubernetes similar to replica sets that helps you to manage a set of identical pods and ensuring that a specified number of pods are always up and running at any given time. It offers also the capability to scale up or down as we did with a replica set. So you may notice that when working with deployment, we can benefit from all the features that we have when working with replica sets. And that's because the deployment manages pods through replica sets. So whenever we create a deployment, one or more replica sets will be created and it will be under the control of the deployment. In addition to all the features that we have with replica sets, the deployment offers you the capability to move your application from the current version to a new version without any downtime by using the appropriate deployment strategy. If the new version introduces some problems, the deployment will allow you to roll back to the previous version instantly. The default deployment strategy is the rolling update strategy. It is also known as the ramped or the incremental strategy. The rolling update strategy consists of slowly rolling out a version of an application by replacing instances one after the other until all the instances are rolled out. And it follows the following process. With the pull of the first version behind a load balancer, one instance of the second version is deployed. And when the service is ready to accept traffic, the instance is added to the pool. Then one instance of the first version is removed from the pool and shut down. And then it will move to another instance until replacing all the pods running the first version. We have different other deployment strategies, and here are some of them. Let's move now to the deployment manifest file. Here we have the YAML file that we have used previously to create a replica set. To create a deployment, we need to make a single change to this file. For the kind property, instead of replica set, we have to set it to deployment. Of course, it is better also to change the name of the file. So instead of nginx rs.yaml, we call it, for example, nginx deployment.yaml. Now this YAML file can be used to create the deployment. To create the deployment, we perform the same steps as we did when creating a pod or a replica set. We execute the kubectl apply command, followed by the -f option and the name of the YAML file. To view the existing deployments, we use the kubectl get deployments command. And here we have only the deployment that we have created a few seconds ago. We can also list the pods created by the deployment using the kubectl get pods, followed by the -l option to get only the pods having the label app nginx. And as we see in the output of this command, we have 3 pods created by the nginx deployment. To get more information about the deployment, we can use the kubectl describe deployment command, followed by the name of the deployment. In the output of this command, you will find the deployment strategy, which is by default set to the rolling update strategy. When the traffic increases and we need more instances of our application, we can scale up using the kubectl scale deployment command, followed by the name of the deployment and the replica option set to the number of pods that we want. We can verify if the deployment was scaled successfully either by executing the kubectl get deployments command or by listing the pods having the label app nginx using the kubectl get pods command. If we need to scale down, we use the same command as we did when scaling up. We change just the value given to the replica option. And if we list the deployments, we will find that the nginx deployment was scaled down successfully. Let's learn now how we can update the Docker image. To update the Docker image used to create the pods, we use the kubectl set image command, followed by deployments / the name of the deployment, followed by the name of the container set to the name of the Docker image. For example, here we want to tell the deployment to use the nginx 1.26 Alpine Docker image instead of the image mentioned in the YAML file. And by default, the deployment will use the rolling update strategy to update the Docker image. To check the rollout status, we use the kubectl rollout status command, followed by deployment / the name of the deployment. Here we see that the nginx deployment was successfully rolled out. Finally, to delete the deployment, we use the kubectl delete command, followed by the -f option and the name of the YAML file used to create the deployment. And of course, when deleting the deployment, add the associated replica sets and pods will be deleted as well. So that's it for now. I hope that everything is clear and thank you so much.